Okay guys, to solve this circuit, what we need to do is find the voltage, current, and resistance across all three of these resistors. In order to do that, we first need to find the total supply current based on all of this. So let's start with current. Now, in order to find current, we first need to find our total resistance. And the way we do that, because this is a series circuit, is we can simply just add all three of the resistances. And we know that resistance is measured in ohms. Okay, so we have our total resistance. Now I use my total resistance to calculate my total current. And the way I find total current is by rearranging Ohm's law, which I know is V equals IR. So this is just a rearrangement of that. So I know my total current is going to be 10 volts divided by 59 ohms. So my total current ends up being 0.169 amps, but of course we can convert that. Actually, let's just leave it as amps. Okay, so we have two of our important quantities there. Just gonna make this a little neater. Okay, so this actually we can write over here. So our total is 59 ohms and I total is 0.169 amps. Now, what we need to know about series circuits is that current flows through each of these components. The same amount of current flows through each of these components. So we can say right away that the current flowing through this first resistor is 0.169 amps. The current flowing through R2 is also 0.169 amps. And the current flowing here is also. So in this case, the current flow is pretty straightforward. And now what we can do is, if we want to find the voltage drop across all of these components, what we have to recognize is that the way I like to think about voltage in series circuits is that 10 volts has to be spent completely across R1, R2, and R3. Okay, so actually the formula we know, the formula we're going to use, we're not actually using this formula. The formula we're going to use is V equals I times R. And we have to do that for each of these three resistors. Okay, so if I know that V1 equals I1 times R1, I can simply just calculate V1 by multiplying 0.169 times 20. And that gives me a voltage drop of 3.39 volts. Okay, so there's all right, and we can write that in volts, of course. Okay, so we can write that in. Okay, now let's try V2 in a very similar way. V2 is going to be 0.169 times 19. So it's just going to be a bit smaller. 3.22 volts. Okay, and for our last one, it's going to be the same actually as V1. Okay, so let's write these in. V2 is 3.22 volts and V3 is 3.39 volts. Okay, and one thing we can check and confirm is that whereas our total, okay, has that equation, we can double check that our voltage abides by the rule for series voltage, which is that V total equals V1 plus V2 plus V3. And we can just check that here. So 3.39 plus 3.22 plus 3.39 does in fact, let me just see what it equals exactly 10 volts. So we know we've done something right, which is good. All right, so we have successfully solved our circuit.